Welcome to my class. We are doing correlation and we are doing Spearman's rank correlation coefficient. And in this, we've talked about when the ranks are given, when the ranks are not given, and when the ranks are the same. Sometimes you find that the numbers are the same. So we have to suppose the grand total for 3 children are the same. So the ranks are bound to be same, but this is how we calculate for coefficient of correlation. So we put it as M. Look at this. This will be the formula. It's the same thing, excepting that 1 minus 6 into sigma d square, that is plus 1 by 12 m cube minus m. So what is m? The number of times the numbers are repeated or the ranks are repeated. Suppose if it's repeated 3 times, then it will be 3 cube minus 3. If it is repeated 2 times, then it will be m square minus m. That means 2 square minus 2. This is how it goes on. Alright. So with that, let me just tell you once again. So what happens is sometimes you find that we find that many times ranks of many values are the same, such as here in the first column or in the variable x, we find that the ranks the ranks 7, 8 and 9 are repeated. So what do? We take their average, and that's how, and what we get is 8. Alright, so and in the next section, in the next set of variables, that is y, what we find is that there are 2 sets of ranks or numbers like 13 and 13, they are repeated, and 6 and 6 is repeated. So what do? We take the 5th rank plus 6th rank. 5th and 6th is equal to 11 by 2, and what we get is 5.5. And in the same manner, 8 plus 9 is equal to 17 divided by 2 is equal to 8.5. So that is how, and then it's the same manner that we do it. That's how we calculate. So let me just explain it to you once again. How do we go about it? Only like for example, now what is repeated? 16 is repeated in this series. What is repeated? 16. Look at this. 48, 33, 49, 16, 16, 65, 24, 16 and 57. So 16 has been repeated thrice. Alright, so how do we go about it? So in this, as usual, what we do is we take the highest number as number 1. Okay, so that is why. So after the value of so what we see is we mark this as 65 is the largest number in the X series, so we rank it as 1. The next highest is 57, we rank it 2. The next highest is 48, we rank it 3. Next is 40, we rank it 4. Next is 33, we rank it 5. Then you have what is known as 24, we rank it 6. Now, the 7th number is 16, but we find another 16, 8th, and also 9th is 16. So what do? So what we do is, can you see the board? Yes. So in the X series, we've seen this. So otherwise it will be 7th, 8th and 9th rank will be 16, 16 and 16. So what do? We take the 7th plus 8 plus 9th rank, and what we get is 24 divided by 3. We take out the average, and what we get is 8. So we put, for all 3, we put it as 8. So till 9 is done, and the last this particular variable 9th becomes, the value 9 becomes the 10th rank. I hope it is clear, and if it's not clear, let's go to the y variables. Okay, now let's just take y. If you just look at it, which is the highest number? 24 here. So we give it the first rank. Which is the next rank? Which is the next highest number? 20. We put it as 2. Which is the next one? 19. We rank it 3. Which is the next one? 15. We rank it 4. Now, which is the next one? The fifth one is 13, but there are two 13s. It's repeated. So what we take is, it will be the fifth and the sixth rank. So what do? In the y series, we've taken 5 plus 6 is equal to 11. We take out the average. 2 is equal to 5.5. So we put them as 5, instead of putting them 5th and 6th, because both are the same, we put them as 5.5 and 5.5. But now 6 ranks are over. We'll go to the 7th rank now. And you see which is the 7th? The next highest number is 9. So 9, we mark it as 7. And the next one is, after 9, it's 6. So that becomes 8th. But there's another 6 that becomes 9. So then what happens is, we'll take 8 plus 9 is equal to 17 divided by 2. We take the average and we get 8.5. So instead of writing 8 and 9 or 9 and 8, whatever, we put it as 8.5 and 8.5. So 9 ranks are over now. And they are 10. The total number is 10. So then the next number which follows is 4, and we mark it as, we rank it as 10. So having done this, then we come to the same thing. We'll get a D. Now what is D? Rank 1 minus rank 2, as is given. Okay, so 3 minus 5 minus 5.5 is minus 2.5. 5 minus 5.5 is minus 0.5. 4 minus 1 is 3. 10 minus 8.5 is 1.5. 8 minus 4 is 4. 8 minus 10 is 2. Then 1 minus 2 is minus 1. 6 minus 7 is minus 1. 8 minus 8.5 is minus 0.5. And 2 minus 3 is minus 1. Okay. So this is how we go about it. And then we will square them up. So how do you get 6.25? 2.5 into 2.5, then 0.5 into 0.5 is 2.25, then 3 3s are 9, 1.5 is 2.25, squared it up, 4 4s are 6, square of, we squared this up, 16, we squared this up as 2 as 4, we squared minus 1 as 1, minus 1 is 1, minus 0.5 is 0.25, and minus 1.0 as 1. Now we have to get sigma d square. So this into this is what we have to do. So that comes to, if you add this up, you get 41. So now, as I said before, m, what does m show? The number of times. The number of times the variable has repeated itself. So that is how we will work out the rank like that. So here we will take as, in the first series, it's how many of them we'll do? 1, 2 and 3. So in the entire, the variables, the first series and the other series, the x series and the y series, in the first series and the x series we have a number that is 16, which has been repeated thrice. So we will put it as m cube minus m. So after we ranked them, so that is how we will, so it's how many times it has repeated. So just write down thrice, 3 cube minus 3. Okay, plus 1 by 12 m square minus m. So how many times? Twice. That is 2 square minus 2, and again it has repeated itself 2 times, so write 2 square minus 2. Is that clear? Okay. So after we do this, we're going to solve it. So Spearman's rank correlation coefficient RS is 1 minus 6 within those brackets 41, that is sigma d square, plus 1 by 2. How many times it has repeated? 1, 2, 3. So write 3 cube minus 3 plus 1 by 12 within brackets 2 cubed. How many times it has repeated? Twice. So 2 cube minus 2 plus 1 by 12. Again, how many times? There has been a pair, that is 2 cube minus 2, and divided by n cube minus n, that is 10 cube, that is minus 10. Alright, so now we're going to work out. So 1 minus, you have 6 into 41 plus 1 by 12, that is 3 into 3 cube is 27, minus 3 plus 1 by 2, 8 minus 2. 8 minus 2 how? 2 2s are 4, 2 3s are 6. 2 2s are 4, 4 2s are 8. Minus 2 is 8 minus 2. Again here 1 by plus 1 by 12, 8 minus 2. And what do? Divide by 1, 1000 minus 10. That is n cube minus 10. 10 tens are 10 into 10 into 10 is 1000. So here what you get is, we go ahead and we do a little bit of, we'll work out a little. I hope you can see this. Yeah. So in this you see that 41 plus 1 by 12, 12 ones are 12 twos are 24. So this is 1 by 2. Okay, 6 ones 2s are 12, 6 ones are 6 2s are 12, 1000 minus 10. Alright, so now I want you to see this carefully. So we come here now. I had to do it at one place. So now for rank correlation, 1 minus 6 into 41 plus 2 plus 0.5 plus 0.5 upon 990. So 6 into 44. 41 plus 2 plus 3 is 44 divided by 990. So again, rank correlation is 6 into 44 is, see, 1 minus 264 divided by 990. And when you divide this, what you get is 0.26. So 1 minus 0.26. So the rank correlation is 0.74. So there is a positive correlation, and this is how we go about it, and I hope you've understood. It is not difficult. You just have to know what are M, how many of them, how many of the numbers are repeating themselves. That's what you should know, right? Only then you will understand. And there is a good degree of correlation between these, rank correlation. Alright, so I want you to take your notebook and do this numerical right now, and go into your book once again. Open your book, find out one of the illustrations, please do it, and after you do that, be very, then go ahead and do one from the exercise. Only then will it be clear to you and you will understand. the more you practice, the better you get. Is that right? So once again, just have a look. It looks to be very difficult, when you see that it's such a huge big formula and all of that, but it is not. If you just need a little practice and you're good to go, right? So with that, we come to the end of say correlation, as we've seen, rank correlation. And in the next one, I think I'm going to do index number. So obviously, if you see the merit to it, this method is easy to calculate and easy to understand as compared to Carl Pearson's method. And the method is really useful when the data are of a qualitative nature, like intelligence, beauty, and all of that. Then when we give ranks instead of actual data, this is the only method for finding out the degree of correlation. And this method we cannot be used for calculating correlation or grouped frequency distribution. So here we can only talk about individual values. If the number of values is quite large, it becomes a difficult task to find out ranks and their differences. And of course, it is not as precise as Carl Pearson's method because it uses ranks only. And original values are not taken into account. Alright, so with that we come to an end of correlation, and please practice